Its effects are multi-tentacled, right? You can see that it affects the housing crisis. It affects food access. It affects transportation. So I think that the impacts of climate change are real, and we are starting to see noticeable impacts from that. Architects have a particular responsibility to make sure that we're sourcing materials that's local or is recycled or has a long lifespan to it or could be reused. Principally, the goal is to drive down the energy demand. As I mentioned, buildings comprise 40% or so of the energy use on our energy grid. And to push down the ongoing operability of our buildings is a huge impact towards a more sustainable future.
Welcome to Mindful Businesses, presented by Sarani, and I'm your host, Vidya Iyer. In our podcast, we bring to you businesses that are mindful in their practices and processes. A mindful business implies sustainable social, economic, and environmental practices. Today, we have with us Ben Wan, principal at Rodi Architects, Transformative Design Through Collaborations. He joins us from Boston, Massachusetts. Welcome, Ben.
Thank you, Vidya. It is wonderful to be here. I'm really looking forward to our conversation.
Without sounding like a broken record, global warming is real. With continuous triple-digit temperatures for a record number of days in states like Arizona, New Mexico, and even in Massachusetts. And the increasing water temperatures, which are now in some places over 100 degrees Fahrenheit. How would you convince the person who doesn't believe in global warming?
Oh my goodness, what a challenge. And if only we could look to some of the other societies in the Western world that are addressing this challenge head on as sort of a united culture. Of course, we have our challenges here in the States. And I think you stated maybe the obvious, and I can't say that I'm a climatologist, but I think all of us are living this experience of extreme weather events. This summer up here in Boston has been unusual, to say the least. The storms have been extreme. The humidity has been off the charts. And we're just seeing that it's all coming together in a confluence of weather, livability, and its effects are multi-tentacled, right? You can see that it affects the housing crisis. It affects food access. It affects transportation. So I think that the impacts of climate change are real, and we are starting to see noticeable impacts from that. As architects, I think what can we do, but we have the responsibility for our built environment. It has been a core tenet of Rodi to be sensitive to the environment where we are building. We understand that our work has tremendous impact in the short term and in the long term. Buildings last for a long time. We recognize it, and we're happy to face that challenge head on.
What is the contribution of the construction industry to the carbon that's emitted in our atmosphere?
I don't know that I have specific numbers on it, but of course, buildings, I know that their energy use ongoing is about 40%, I believe, of the total energy demand that is consumed annually in the United States. But also the efforts that go into constructing, maintaining a building, the embodied carbon, as you mentioned, of all the materials. Architects have a particular responsibility to make sure that we're sourcing materials that's local or is recycled or has a long lifespan to it or could be reused, that have, buildings, I think now that we're building them, have sometimes the goal to be deconstructible in the future, knowing that their lifespans might not be infinite.
We had a guest from the Netherlands, and he said in Europe, they're moving from concrete buildings to wood because wood, of course, can be regrown, the trees can be regrown, and it's considered more sustainable than concrete.
Yes, we do have a project here in the office that is exploring. It's CLT, cross-laminated timber. It's essentially, you could call it mass timber construction. I know that there's some tall buildings out on the West Coast. I think Portland and Seattle are doing some great work to spearhead projects in this area. Massachusetts has incentives, and there's programs that offer developers and designers financial assistance to evaluate the possibility of a CLT, cross-laminated timber, sort of mass timber projects. And one of our projects that we are working on now in Worcester, which is sort of Massachusetts' second city in the center of our state. It's a multifamily building. It's 9 to 10 stories, and we are looking at passive house and CLT for that building. So it's not only going to have ongoing a sort of low energy use from passive house, and I know that we'll get to passive house later on in the podcast, but also CLT. So that's a structure that can be built taller than typical 2x4, 2x6 wood construction. And that inherently, as you said, has much lower embodied carbon than concrete and steel or all concrete buildings. It's right now the costs are a bit higher on it. So those incentives are really critical to have partnerships from our public agencies and from our municipalities to help us make sure that we have the opportunity to evaluate that. But the buildings are beautiful. You can leave it exposed at the interior. And so you start to have this warm character of wood at the interior of what these will be apartment buildings. And the structure is also the finish. So it's essentially performative, it's expressive, it's hitting so many of these check marks that I think make architects excited. And it has this great sustainability narrative as well.
So right before the recording, when we were chatting, I mentioned I was from Buffalo, and you said this would be a great place to build a passive house. Why?
Oh, when I think of Buffalo, I think of, the lake effect. I think of extreme weather. You certainly have, we like to think that we're hardy Bostonians, but I think it pales in comparison to what you endure out there in Buffalo. So the winter livability of a passive house, as I'm sure your listeners are aware, makes a building that is super airtight and that is well insulated and that is essentially comfortable throughout all of the winter with a very low mechanical system demand. And also, of course, the system works in summer. I actually don't know Buffalo summers if they're as humid or as damp.
It's perfect.
Perfect.
Like we were just talking to a friend this morning and I said, it is always temperate.
You earn it from your winters. Yeah, if you can make it through the winter, then you earn the beautiful weather in the summer.
Yeah, and it's beautiful. It's green and we have the lakes, and which in summer is beautiful. The passive house as a concept was started in Europe. Firstly, it's not a brand. It's a construction concept, right?
Yes, started in Germany many decades ago in maybe the 1970s. The first projects from Germany were built using this method. And it's taken a little while to come to the States, but I know since the turn of the century, FIAS, which is the United States, the Passive House Institute of the US, was established. From that point, there's been sort of a propagation of these, mostly starting with single-family homes, but recently growing into larger scale buildings across the United States. But you're right, it's not a brand. It's not like a product that you can sort of select and build. It's a building method, and it's sort of an energy approach to looking at buildings. Principally, the goal is to drive down the energy demand. As I mentioned, buildings comprise 40% or so of the energy use on our energy grid. And to push down the ongoing operability of our buildings is a huge impact towards a more sustainable future. We can get into all the nitty-gritties, the details of what passive house is, but
when people think about a sustainable house, they think if you slap on a few solar panels, you're done. And I think that should be probably the final steps of the whole process, right? And we've spoken to other experts in the field, and they said your project should start with trying to reduce your overall energy consumption. And with the passive house, you do that with a really, really tight envelope. How do you get that envelope? What are the materials that are possible to be used?
Yeah, maybe it's useful to just go over those principles of passive house, I guess we could call them. And we're even just speaking about passive house. There's the sustainability of a building, sort of has tentacles that branch out into many other directions as well. But in terms of just passive house and that specific goal of driving down the energy use of a building. EUI, maybe you've heard this acronym, it's the energy use intensity of a building, and that's one of our standard metrics for how we measure energy demand from a building. That main goal, yes, is to build an envelope for the building that is airtight and that is operating sort of like a thermos. It's making sure that whatever energy you're putting into treating the interior air of your building is retained. So that lowers the demand for your mechanical equipment. You can even shrink mechanical equipment compared to a house of a comparable size. And you do that by extra insulation. So sometimes the walls of a passive house will be a little thicker. Instead of a 2x4 or 2x6, you may want to go to a 2x8 so that you can get a little bit more volume in the cavity for that insulation. And then often there's an external continuous insulation that's applied to the exterior, just to make sure that that wall has a very high R value being the sort of thermal conductivity of a wall. You do that, but then you also have to have what is a building membrane. So it's an air barrier applied to the surface of your building sheathing. And those are used in most residential construction. But the key here is you need to make sure that it is a membrane that is of a high enough quality, that it does have a very low air permeability, and also pay crucial attention to the detailing of the building. Anytime there is a transition in materials or a fastener or a sort of any of those moments where the buildings inevitably have to navigate a transition, you have to make sure that it's taped and sealed and airtight. And that translates to all of the openings, the most significant of which are windows and doors. So windows, you need triple glazed windows. That's just essentially, you must have triple glazed windows. And luckily, many more manufacturers on the States side are coming out with accessible triple glazed window products because demand for passive house is increasing. Any doors and door frames have to be thermally broken so that there's good gasketing and seals that maintain some of those airtightness. And then once you have those elements, then you essentially have your airtight, your product. And one critical design move that we have to do as architects is cutting a big section all the way through the building and just tracing that air barrier line and making sure that you can identify its continuity throughout the full perimeter of your building.
You used the word thermal breaking. What does that mean?
Sure, thank you. Basically, paths where the exterior air has a easy mode of transmittance to the interior. So think products that have high conductivity like metals. So if you have metals are clearly the best product that we have for securing exterior finishes to the building and making sure that there are moments where either, if that is inevitable, it is well sealed and treated, or where possible to actually have a break in that material. So we have buildings where we have, the concrete foundation of the slab may need to transition from interior to exterior space. So designing that so that there's a gap where you can fill in with insulation so that the thermal conductivity of concrete, which also, sitting in contact with the ground, has an opportunity to prevent that external temperatures transmitting to the interior. And then you're starting to affect the thermal sort of air quality of the interior air.
Insulation and R values kind of go hand in hand. In a typical passive house, what are the R values that you would like to achieve?
Sure, of course. One important part of passive house analysis is bringing on an energy modeling company. We don't yet do that in-house, but we're working on it. We worked with a company out of Maine, Opal Architecture, to do some of our energy modeling, and they'll look at the building comprehensively. As you're looking at a building initially, massing and orientation are important. So this, considering the path of the sun, making sure that you have a compact form so that you have a fairly low proportion of envelope to interior air that's treated is a very important starting point. And that will start to drive some of the R values that each of those facades need to be given to provide the appropriate thermal conductivity that's needed. So I actually brought up a section from a project.
Is it like R26?
We can get, here we had higher R values, R40 or so across the entire facade. So that was that cavity insulation plus the exterior continuous. And then actually the roof is very important. You like to say that heat can rise and can be easily lost through the roof. So there we had higher, between R60 to R80, depending on the orientation and roof forms of the building.
So the R values can be achieved by two components, the materials that you use and the thickness.
That's correct.
So what are optimal materials? Or is there like a ratio? If I use, say, now you get these, waste fabric insulation as against our fiberglass, the pink stuff that we're all familiar with. Would there be like a ratio or some sort of a correlation if I use this, or even like a very dense foam, right?
So this actually gets back to something that you were alluding to earlier in our conversation, the embodied carbon. This is an opportunity as you're specifying the materials of building, as you're assembling it, to not just think about that passive house final goal of driving down the energy use of the building in perpetuity, but thinking about the building that you're going to be constructing on day one or day zero. What is the embodied carbon of that building? And that's somewhere my firm, Rhodey Architects, we're really looking to expand our knowledge base and our product knowledge there, thinking about what are the best products that are high performing, but that are also contributing to sort of a holistic net zero building. The products that we used at a project that was recently completed within the past year down in West Roxbury, they're called the Brucewood homes. There we had the 2x8 wood studs and worked with a structural engineer to space them at 24 inches on center. So studs could be 16 inches or 24 inches on center. If you can get them spaced wider, if you can engineer the building appropriately, then you have a bigger cavity. And then you have a more effective space for that blown-in insulation. And so there, I just said it, we used blown-in cellulose. So that's that recycled material instead of the sort of fiber bats that are put in. And that has a good environmental history to it. And then at the exterior there, it's a mineral wool product that can be applied continuous to the outside of the building instead of sort of an expanded foam product. The blown-in cellulose is great for the walls. We use it at the roof as well. And then the mineral wool is good for the exterior continuous. And then there is a foam product that we used below the concrete slabs in those buildings to separate the building from the earth as best as we could.
And maybe the seams and all that.
Exactly correct. And then there's a spray foam product as well. Try to use that minimally because that's not the best environmental product, but it is the best at just filling in those last gaps and managing some of those trickier transitions.
When you have a 2x8 as against 2x4, and even if you're putting it 24 inches off center as against 16 inches off center, you're almost like 60% more.
A quantity of material. Absolutely. Yes.
That is like building a house and a half the lumber that you would use.
Sure.
Is the energy saving sufficient to recoup that additional cost?
So if you are using the 16 inches on center, it requires less engineering. So there's less maybe upfront cost. It doesn't require the coordination as much, but that's more material. And you have less insulation within the walls. So it's quite advantageous to spend the extra time in the planning and design phases to use that wider spacing, make sure that it coordinates to a floor structure that can be borne by that wall. But the benefits are huge, obviously, because then you can have that larger area in the cavity of the wall to provide that blown-in cellulose, which has much better R value than a wood stud.
How do you justify that additional cost?
So luckily, these homes, the homes I was referencing down in West Roxbury, they were completed a year ago. So now we have a good year of data on it. And the energy use of all three homeowners, almost net zero. They do have solar on the roof, so there's some renewables that are offsetting their energy use, but they are saving many thousands of dollars a year on their energy costs. So it's financial.
How big are these homes?
They're fairly modest. Yeah, they're 2-story homes. They actually in an existing residential neighborhood. So the homes that were on the street, we wanted to make sure that the new buildings we put back comported with the scale and the character of the street. And even though we are contemporary designers and went with something that represented the forward-thinking contemporary design of Passive House, they still have forms of the homes on the street. They have gabled pitched roofs. They have clapboard siding. But your long-winded answer to your question. They're about 1,800 square feet each of occupied, treated, habitable space. So they're 4 bedrooms, kitchen, living, and a dining room, really sort of approachable.
Another important thing, as our listeners can imagine, if something is really sealed tight, the first thing is like, what do you do with the stale air?
Yes.
In Passive House, that's a very important component, the energy recovery ventilators or ERVs.
So my home that I live in, a 100-year-old home, and it just leaks. It's almost meant to, right? The air needs to move through it. It needs to dry out in that way. But these homes, of course, built with modern construction techniques and the super airtightness of the building. As I mentioned, the mechanical systems, this is sort of your standard heat pump where there's outside unit and then the refrigerant lines go toward the inside unit, and that's it's heating or cooling the air as needed. But that's an airtight system essentially, right? The refrigerant lines can just be sealed in their penetrations. So because of that, we want to avoid sick building system and we need fresh air changes for the building. So there is that ERV piece, the energy recovery ventilation. And so that's a duct that pulls in fresh air. It does have heat recovery. So as it's pulling in fresh air, it can either use or reject the heat as needed, depending on the season, whether it's coming in or out. And then that air from the ERV is combined with the treated air that's coming out from the fan coil unit within the building.
The ERVs come and they go through the heat recovery system. Would they be what we call the heat pumps?
I'd say no. They work in tandem with the heat pump. So the heat pump is what is doing the primary conditioning for the home. It's what's your main source of heat or cooling, of course, depending on which season you're in. But the ERV, because it is sourcing air from the exterior to make sure that there is a continuous as needed supply of air for the air changes, is able to find efficiencies in it's making sure that it's not exhausting heated air from your home in winter. It's recovering the heat from it, exhausting the air, and then transferring that heat to the incoming air that's pulled in from the exterior. So it's just another way of making sure that while we're bringing in fresh air from the exterior, we're not losing the inherent energy of the tempered air as we're exhausting it.
Do these ventilators have like a hum or buzz? Part of the quality of a house is to have a quiet, peaceful house with good quality air, right? So are they noisy?
I wouldn't say. I haven't actually been in the room with these in this house listening to them, but
You haven't had feedback saying that, oh, this hum is annoying.
I think the good part of this is that it's the movement of air. It's not necessarily the intensive treatment of air that is happening with, say, a typical furnace.
Is there like a metric, the amount of air that you need to exchange? Like, is there like 0.6 per hour?
When we finish the building in construction, one of the key metrics to make sure that that the contractor has built it per the design is to do a blower door test. So they'll seal off the openings, they'll put a big fan into the front door, and they'll essentially run a pressure. And there's tools for them to measure how much of that air leaks out. And there is a threshold of 0.6 that cannot be exceeded in that final construction in order to be certified as a passive house. And all 3 buildings that we constructed in West Roxbury passed well below their thresholds, below 0.5, even approaching a 0.4 air changes per hour. They were well built and they're performing well.
I've heard of fuel pumps in the context of geothermal systems. Can they be used in any sort of system? Because I'm very confused about the fuel pump. I can't wrap my mind around like how exactly it does it. With the geothermal, which we are having in our house, I kind of like can understand it somehow. But in a place where there is no geothermal, I'm not sure how they do it.
Some of these mechanical systems, although we're using models that are extremely high efficiency, so they're more efficient than the standard that someone might put in their own home, it's still very similar mechanical system to what someone might put into their house for, say, air conditioning or heating. I actually put one in on my house. It's a mini split system. So it has the condenser outside. It has the refrigerant lines that go to a unit inside of your house, and it's refrigeration, just like your refrigerator. It's pulling out hot air through compressors in sort of that refrigerant, and it's going to be a mechanical engineer that can describe it better than I can, but still, it's a unit at the interior that's either pulling out heat or pushing out heat through the chemical reaction of the refrigerant lines, blowing your inside air over that refrigerant line. It's transferring the energy to that, and then those refrigerant lines move through the sort of your wall or along the exterior at my house at home to that outdoor condenser, and then it's exhausted, and the process repeats itself in it first.
Windows, we have the U factors that we want to achieve, and the lower the U factor, it is better. And whereas in terms of the R values, the higher the number, the better.
Yes. And I don't have the specific U's of the window types that we used at these homes, but the triple glazed, they have excellent U values. They're tilt and turn. So it is a technology that's sort of come over to us from Europe. And that tilt and turn technology gives you a nice tight seal at the window instead of a double hung.
That's what we have in our home.
Okay.
I had to put my foot down with the contractor, do all my research, source, and get those. Yes, I've been looking for those windows for 20 years now.
Yes, they're still harder to get. We had scale, so it was a little bit easier for us to do it. We were building 3 of these. They're getting easier, though. I don't know if you know, but in Massachusetts, we've adopted the new energy code, and it's pushing almost towards passive house. It's essentially meaning that you need to do many of the steps and many of the design decisions very early on in your design process. Even from the massing, there's energy modeling that will be required that was not before for buildings of a certain scale very early on in the design process because the requirements are so high under this new energy code. It's starting in Massachusetts. It's going to spread as well. Yes.
But Massachusetts is one of our historic old cities in America with beautiful buildings, which are at least hundreds plus years old. We lived there at some point in time, and our house was built, I think, in 1880. How will they achieve the energy code with so many old buildings? Do we tear them down? Is that a better solution? Or do we build an exterior wall around these old buildings?
Sure. Even at that point, you have other concerns about historic preservation. You can't just put a new facade around a historic building. I think this is just one of those ways where, as we mentioned earlier, sustainability has these tentacles that tend to have repercussions and require really comprehensive thinking to be able to balance the tension between sometimes often competing factors. I think that's one of the things that architects are often tasked with. We're not necessarily the mechanical engineer, we're not the landscape engineer, we aren't the city municipality, but we are the ones that have to sort of pull the connecting threads across all of those different parties to make sure that they are in alignment and find out and advocate for what's best for the project. And so if you have a historic barn building, what's your budget? Maybe you can pull off the interior finish, blow in something, and then specifically and carefully reapply that interior finish. It's been done before to see some of these older buildings made habitable for the future, but it won't necessarily be the perfect solution for everything. But at least this energy code will make sure that everything new that's being constructed from here on out is going to meet these high standards.
When you talk about a budget, and in this case, you said if you had a budget, you could make it sustainable. And even the new build, your budget is at least 20, 30, maybe even 40% higher than a traditionally constructed home. In the United States itself, about 12% live below the poverty line. That's 38 million people. We cannot make this journey without everybody coming on board with us. How do you make it accessible? Do you have a solution as an architect to make it accessible?
This is one of those whale of an issues that just is facing us as a society. I think many partners, having the right partners, we are working on a project that is expected to break ground in the fall. It is a 100% affordable multifamily apartment building in Cambridge, Massachusetts that is designed to passive house. This project is, of course, it's on a brownfield because it's an already built out municipality where often not the choicest sites are remaining. So there's a ton of remediation that is required. There are, of course, we're a coastal city, so there are flood zones that we have to consider. There's resiliency issues that we have to design in. Passive house helps with that, actually, because it does provide a building that will have additional habitability in any kind of severe weather event. But really, it's having the right clients in place who are willing to sort of design with a mission. That's one of the sort of taglines that we like to rally around here at Rhodey Architects. And Just a Start is our client there. They're a nonprofit developer.
What is the name of the nonprofit?
Just a Start is the nonprofit developer. That is, they have a portfolio of affordable housing, but they also have supportive job training programs. So they're providing sort of comprehensive supports for people in the municipality of Cambridge, but also the partnerships of the city. And we're working with state funding sources, municipal funding sources to all rally around and make sure that this affordable housing project can be realized. And it's actually the first of affordable housing projects in Cambridge that was approved under the city in the AHO, which is the Affordable Housing Overlay. So Cambridge decided as a city that there was a demand for affordable housing and that they would pass a ordinance to their zoning code that would allow affordable housing on any parcel in the city. And it allows for greater density and a more streamlined permitting and approval process. So this is the first project that was able to make it through that process. And Passive House was one of the incentives that the city encouraged the developer to pursue and assured them that there would be the funds to help support that expiration.
So there is hope.
There is hope.
We've covered a lot about the design features in the passive house in the context of individual homes. In this multifamily development, were there any particular changes or features you had to incorporate to make it for you to be able to achieve the goals that you had in mind?
In this project, it has this very challenging and interesting site. It's very long and very narrow. So we wanted to make sure that the massing of it didn't feel like sort of this massive building as it was new for the district where it was being built. So we had to make sure that the massing was carefully articulated so that it fit within its neighborhood.
When you say massing, what do you mean?
The sort of overall form and scale of the building. So it's making sure that we don't have the site is more than 400 feet long. Any building that has a continuous unbroken cornice line that's 400 feet long just feels inhuman and not of its scale.
Like a prison.
Exactly. So we worked with Opal, again, a consultant, to help us navigate passive house ideal requirements. And we came up with a scheme that shaped the building around 2 courtyards that opened up views to the adjacent park or longer views to a distant reservoir. And what that did was it helped to shape the building's mass, to break down the scale of it and provide a more sort of human scale to the building, but also worked to make sure that the solar orientation of the building was good where we wanted it, where you had good light coming into the apartments, but that also we were reducing the number of facades that had that strong southern heat gain exposure. So there was sort of a confluence of design, response to the context, into the neighborhood, paired with an eye towards what is best for the passive house model and what will provide a strong performing building. We were able to find the solution that navigated both of those towards an elegant solution. That's something that we, again, at those homes down in West Roxbury as well, how can we make sure that we're approaching sustainability and the sort of very technical requirements of smart energy design? How are we making that beautiful? And how are we making it the synthesis of space in a building that is contributing to its place and to its neighborhood?
When will this project be available?
We'll break ground in the fall, and it's about a 2-year construction timeline. As I mentioned, there's a lot of below-grade ground improvements we have to go through, so it's going to take a while for us to get out of the ground. But once it's up, it should be 20 to 22 months of construction. So that would put us into 2026.
Wishing you all the best. Thank you so much for all the work that Rodi Architects do. It's a mission-driven firm. And thank you again for sharing your projects with us.
Thank you for the opportunity to talk about this. Passive House is growing rapidly, and so I think your listeners will start to hear much more about it, hopefully in states across the nation.
Thank you again, Ben. This is Ben Wan from Rodi Architects. You're listening to Mindful Businesses, hosted and produced by Vidya Iyer. We'd love to hear from you. Send an email to info@mindfulbusinessespodcast.com. If you learned a thing or two from this episode, share it with one friend. Click on the subscribe button to be the first to learn about our latest episodes. We recorded the podcast in Buffalo, New York. Theme music was composed by Tatum Gale. Roseanne Kurian is our marketing assistant. Ketan Karat is our podcast editor. Our advisors are Jim Stone and Anupama Pastrija. This is Vidya Iyer with Mindful Businesses.